Okay, in problem 719, we are given the probability distribution of x. And we're going to start by doing some calculations that we have already practiced in the previous problems, but let's do it again. It would be a good opportunity for you to try it on your own. So I really strongly advise you, before you continue watching this video, why don't you try yourself to find the mean, the variance, and standard deviation of x. So stop the video now, try to do it, and then continue watching the video to see if you got the right answers. All right, so let's do it together. Mean, you remember that first of all, again, I always make sure that I have the sum of the probabilities to be equal to 1 to make sure that we are not dealing with the wrong probability distribution. And then to find the mean, it's sum of xp of x, as we did before. So I add the column for xp of x, and I multiply each value of x by its corresponding probability. So this is what we are doing, right? We are multiplying 0 times 0.4, it would be 0, and then 1 times 0.3, it would be 0.3, then 2 times 0.2, 0.4, and 3 times 0.1, 0.3, and here we go, we put them here, and because we're looking for the summation, so we sum up these and we get 1, and that would be our mean. All right, that was very straightforward. Now the variance. Variance, remember, it's x squared p of x, so we do that first and then we subtract the squared mean. So we add again a row for x squared p of x. The first one is 0 times 0.40, and 1 squared, it's 1 times 0.3, 0.3, then 2 squared, right? Then we remember that we are squaring now x, so this will be 2 squared times 2 squared, which is 4 times p of x times 0.2, so 4 times 0.2, 0.8, and here we go. See, this is what I was referring to. Then this one, what's that? It's x squared, so 3 squared, which is 9 times 0.1, 0.9. And to find the summation, we sum these up, and then we subtract from 2, we subtract 1 squared, and we get the variance. So the variance is 1. Standard deviation is very easy because it's only the square root of the variance, so that's 1. All right, now B, we are given that y is equal to 3x plus 2. And the first part, for each value of x, determine the value of y. So how to do it? Let's first add this row, y. Y is 3x plus 2. So when x is 0, okay, x is 0, what would be y? We simply substitute x with 0, so it's 3 times 0, 0, plus 2, that's 2. Now, when x is 1, again, I substitute here with 1, so 3 times 1, 6, plus 2, that's 8. 3 times 1 is 3 plus 2, that's 5. Then, for x equals 3, I substitute x with 3. 3 times 3 is 9, plus 2, that's 11. 3 times, I'm in 2, I'm very sorry about that. Okay, it's 3 times 2, that's 6, plus 2, it's 8. And then for x equals 3, 3 times 3, 9, plus 2, that's 11. All right, I don't know why I was always one step ahead. Okay, so these are the values of y. And now, what's the probability distribution of y? Remember, what's a probability distribution? It's a table that shows for every value of that variable, what's the corresponding probability. So I have here to add a row showing the probability of y. Now, the question is, how do I do that? How do I find the probability of 2? That's easy. Because in which case y is 2? Y is 2 when x is 0. And what the probability that x is 0 is 0.4. And that makes the probability of y equal to be equal to 0.4. The same logic happening here. In which case y is 5? Y is 5 when x is 1. And this has a probability of 0.3, which means that this probability is the probability that y is equal to 5. And the same happen here and there and here. Now we have a very nice probability distribution of y, which was a variable that's function of x. You see, so if you have the probability distribution of a variable x and you have another variable that's function of that x, you can easily determine the probability distribution of that new variable. This is very, very powerful. All right. Now, part C, calculate the mean, variance, and standard deviation from the probability distribution of y. Now that's easy. We'll do exactly what we did for x, but let me first clean this up, okay, so that it would be clear for you. You don't get confused. Sorry. All right, here we go. All right, let's start. Also here, I strongly advise you to do it yourself. So why don't you stop the video, try to do it, and compare your answers with mine. All right, so the mean of y, again, I'm going to use that equation that was given on the top. Mu is sum of x p of x, but now I have y, it's exactly the same, so it's y p of y. So what I do, I add a row here, y p of y, I multiply every value of y by the corresponding probability, so it's 2 times 0.4, that would be 0.8, 5 times 0.3, 1.5, 8 times 0.2, 1.6, and 11 times 0.1, 1.1. Then I sum it up, and this will be my mean. Now to find the variance, again, I'm going to refer to that one. The variance is the summation of the square of the variable times the corresponding probability, and then I subtract the mean squared. So I add here y squared p of y. Y squared for the first one, I have 2 to the power 2. It's 4 times p of y times 0.4, so that's 1.6. And the same apply for all the others. So the summation is 34. So the variance of y will be equal to 34, which is this one. Okay, it's the first part. Here we go. And then I subtract the squared mean, which is this one. It's 5 squared. So I get the variance to be 9. Standard deviation, it's simply square root of the variance, and this is equal to 3. Okay, I hope that you found that easy. Let's proceed. Okay, now we're continuing this problem, 719, and in part D, we are asked to use the laws of expected value and variance to find the mean and the variance of y instead of building first the probability distribution of y. So we want to use our knowledge for the mean of x and the variance of x to find the mean and the variance for y. All right. So what do? We know the laws, right? We know the law of expected value. For example, E of x plus c is E of x plus c, etc. So let's use that. In part A, we found that the variance of x is 1, and the mean of x is 1, and the variance is also 1. Okay, so what's the relationship between x and y? Y is 3x plus 2. So if I want to find the mean of y, all what I have to do is to substitute y with 3x plus 2. So E of y is E of 3x plus 2. Okay, I notice that this is a constant. So that will allow me then to use the law which says E of x or E of z plus c is E of z plus c, where z in this case is 3x. So that allows me to write this as E of 3x, which is the variable part, plus the constant 2. Then I see that this is similar to c times x. And I know that the expected value of cx is ce of x. So I can write that. All right. Now I can substitute e of x with 1 that I know. So e of y is 3 times 1 plus 2. And here we go. It's 5. This is exactly what we found using the probability distribution of y. Okay, let's proceed. Now we want to find the variance of y from the variance of x. So let's see how we can use the laws. Again, I will remind you of the relationship between y and x. So we have y equal 3x plus 2. So v of y, the variance of y, is the variance of that 3x plus 2. So I put this between the parentheses. Now, remember that v of a variance, v of a variable, let's call it w, so that you don't get confused with this x. So v of w, where w is a constant, is a variable plus a certain constant, right? What is it? It's equal to v of w, right? Because the constant does not contribute to the variance. So this will allow me then to say that v of y is then v of 3x, right? It's only the variance of the variable part. Now, also this will remind me of the law that says v of cx is c square v of x. So now this is equal to 3 square v of x, and I substitute v of x with the variance, which I know it's equal to 1. So it's 9 times 1, and that's equal to 9. And the standard deviation, that's very easy. It's only the square root of the variance. And here we go. These are exactly the same answers that we got using the probability distribution of y. And you can now imagine how powerful are these laws of expected value and variance. All right, let's proceed with more problems.